Thanks. Good evening, everyone. Welcome to our physics class. Okay. Today we are diving into some of the most fundamental principles in all of physics. That is Newton's law of motion and the conservation of momentum. These concepts are absolutely everywhere, governing how objects from tiny atoms to massive galaxies, okay, how they move, how they interact with each other. Okay, so these concepts very fundamental concepts. Okay, so I will share one video to get us started. Think about the incredible power of a rocket launch. Imagine the massive rocket sitting on the launch pad. It stays perfectly still, held down by its own immense weight. That is called as inertia. This is Newton's first law at play. Okay. Then, with a thunderous roar, it ignites its engines, blasting hot gas downwards with immense force. In reaction to that downward force, the rocket is propelled upwards. You can see that. Yes, the rocket is propelled upwards with an equal and opposite force. That is the Newton's third law. Okay. Okay. Now you can see the speed of that rocket. Okay. The incredible speed it gains is a direct result of the force applied by the engines, perfectly described by the Newton's second law. Okay. And as it burns fuel, its mass changes, affecting its momentum. So we see all the three laws and the principle of conservation of momentum in one single video. Spectacular event. You can see that. Yes, that is the power of what we are learning today. Is it clear? Okay. All right. So let's get our brains warmed up. I'm going to share one quick quiz. Okay. Please wait. I will share your screen. Okay. So these are the uh, three MCQ from our earlier classes. Okay. All right. You can unmute yourself and tell the answer if you know that answer. Okay. Right. Or you can type in the chat box. First question. A car moves with a constant velocity of 20 meter per second for 10 seconds. What is the total distance traveled? In that sum, the car moves with a one velocity that is 20 meter per second for 10 seconds. So what is the total distance traveled? Option 2 meter, 20 meter, 200 meter, 2000 meter. Yes, already one. Yes, 200 meter. Very good. Any other option? What is the total distance traveled? Here you have velocity and as well as time. So what is the formula of distance? Yes, another one response GJC Chitu. Good. 200 meter. Yes, any other school? Okay. Ah, tell. Target 2025. Ah, you can say that answer. Okay. Ah, okay. 200. 200. Okay. Right. So velocity is equal to distance by time or displacement by time. Okay. So displacement is equal to velocity time. So 200 to 20 into 10, 200 meter. Yes. Okay. Good. Very good. 200 meter. We will see the answer later. Okay. Then next question from the previous class, projectile motion. In projectile motion, okay. So change your name into the school name. Okay. So 97012599947.
దీంట్లో
Change. Okay. So next question, already one response, GJC. Okay, very good. Good. Next question. In projectile motion, what factor causes an object to follow a curved path? Already you know that in projectile motion, all the object makes that curved path. Yes. So, but what is the reason? What is the cause? Very good. One response. Any other response? In projectile motion, what factor causes an object to follow a curved path? Air resistance only, or gravity, initial velocity, the object's mass? Which one? What factor causes an object to follow a curved path? Yes, good. 3. U cos. What is the meaning of U cos? U cos theta. Oh, okay, okay. So 3 initial velocity? No. So gravity is the reason. Okay. In projectile motion, that factor, that is gravity, causes an object to follow a curved path. Only gravity. Okay. It is not like initial velocity or object mass. Already you know that it is independent of object mass. So and as well as air resistance only. Okay. So gravity is reason. Very good. KGBV. Very good. Super. Gravity is the reason. Okay. Right. And then final one. Third one. A ball is thrown vertically upward. At the highest point, what is its acceleration? So if you throw the ball up vertically upwards, it goes like that. Okay. In the upward direction. At the highest point, it will go into downwards. Like already you know that. So at the highest point, what is the acceleration? 0. C. Already one response. Very good. CJG. Saudagunda. Ah, yes, good. 0, 0. Many of the people telling 0. No, no, no. C, yes. Many of the students also telling C. Option C, 9.8 meter per second square downward. Good. So this is the answer. At the highest point, that object goes downward. Yes. So gravity pulls downward. That acceleration due to gravity 9.8 meter per second. Already we know that. But in the direction, it downward. So 9.8 meter per second square downward. Because at the highest point, the object will come to downwards. Okay. Now we can check the answer. Yes, a car moves with constant velocity. Answer is 200 meter. In projectile motion, what factor causes an object path? Gravity. Yes, good. Some of the students telling correct answer. A ball is thrown vertically upward at the highest point. What is its acceleration? 9.8 meter per second square downwards. Very good. Great. Super. Right? Good. Okay. So thank you for your answer. Now we let's lay out the core concepts for today. First, we have Newton's three laws of motion. So, first law. First law. It is also known as law of inertia. Law of inertia. An object at rest. An object at rest. An object in motion stays in motion. So, an object at rest stays at rest. An object in motion stays in motion with the same speed and in the same direction unless acted upon by the unbalanced force. So this is a first law. An object at rest always stays at rest. An object in motion always in motion with the same speed and in the same direction unless acted upon by the unbalanced force. So if you give the external force, you can change that position. You can change that state, like rest to motion, motion to rest. So this is the first law. That is law of inertia. Okay. Now we will go into the second law. Second law. The acceleration of an object is directly proportional to the net force. That force acting at that object. Okay. The acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Okay. So acceleration inversely proportional to the mass, like that. 1 by mass. So inversely proportional to the mean. Okay. Right. So we can write this as a famous equation. So this is A, this is F, this is A, this is 1 by M. So we can rewrite like F is equal to MA. Okay, F is equal to MA. This is the second law. Okay, next one, third law. third law. For every action, there is an equal and opposite reaction. This is a famous third law. Already you know about that law. Okay. So these are all the Newton's 3 laws of motion. Okay. Next, we have the concept of momentum. Momentum. So it is denoted by P, letter P. Okay. So momentum is essentially mass in action. Momentum momentum is essentially mass in motion. Okay, sorry, mass in motion. So it is calculated by multiplying an object mass by its velocity. Mass into velocity gives momentum of that object. This is clear. So momentum is nothing but mass in motion. We can calculate the momentum of one object by multiplying its mass by its velocity. That object mass and that object velocity. So we will get the momentum of that object. So for example, if one car is there, so car weighs like 70 kg, 80 kg, like that, and its velocity 5 or 10 or 20. So you can multiply 4 into 70 into 20, 70 into 10. Then you will get momentum of that car. Okay. So formula P is equal to mass velocity. This is a formula for momentum. So here you can see that P is directly proportional to mass and directly proportional to V, velocity. So the more massive an object is, or the faster it's moving, the momentum more. Okay. So the more massive an object means it weighs higher, like 1 ton weight or 2 ton weight, like that. Or it faster. When it is moving, it goes in a faster mode. Okay. So that is velocity increases. So then we will get more momentum. Okay. Okay. So P is equal to M into V, mass into its velocity. The more massive an object is, or the faster it's moving, the more momentum it has. That car has more momentum. Okay. So this leads us to the principle of conservation of momentum. Okay. Principle of conservation of momentum. So these principles state that in a closed system, closed system means there is no external forces are acting on it. Okay. The closed system meaning no external forces are acting on it. In closed system, total momentum before collision, already you know that about that term collision, yeah, or explosion. is the changes total momentum after collision, which is equal to total momentum after collision. This is a principle of conservation of momentum. Okay. So in a closed system, there is no external forces acting on that object. Total momentum before the collision, which is equal to, which is same as the total momentum after the collision. Okay, right. So take that example of game of billiards. In that billiards game, so here you can see that one white ball, like a cue ball. Here you can see that track. So ball is there like that. Like that. Okay. So before the break, the total momentum 0, because that object has mass, but it is at rest. So there is no velocity. So there is no momentum. So total momentum before the collision 0. Okay. After the cue ball strike the rack, the balls scatter in all direction like that. Yes. But if you put add up momentum of every single ball, so this is a one ball, this is a second ball, so you can add the momentum of every single ball. The total momentum would be 0. So this is a law of conservation of momentum, principle of conservation of momentum. The momentum is conserved. Conserved means does not change. So before the collision, after the collision. Okay. Okay. By the end of our today's class, you will be able to state and explain Newton's 3 laws, define momentum, and use the conservation of momentum to solve problems. Okay. You will also be able to see the how these ideas apply to real world situation like sports and vehicle safety. Okay. Okay. Good. So theory is great, but let's see these laws in action. I am going to share a one screen simulation to help visualize this. Okay. Okay. So first, let's look at Newton's laws, Newton 3 laws of motion. See, in the first paragraph, first law, that is also known as law of inertia. So which means an object at rest stays at rest, and an object in motion stays in motion at constant velocity unless acted upon by the external force. Okay, right. So now I will start the motion. So the object goes. Okay, there is no external force. So that object is at rest. So it always at rest unless acted upon by the force. Okay. So if I start that motion, so then I will apply the friction. So friction means external force. Now you can see that. Now I am applying friction. Friction applied. Ball slowing down due to external force. So the state of motion changes from motion to rest when we apply external force. So this is a first law of motion, that is law of inertia. Okay. Then we will move into the next law, Newton's second law of motion. F is equal to ma, mass into acceleration. The acceleration of the object is directly proportional to the net force acting on it and inversely proportional to its mass. Already you know that about the that is definition of the second law. Okay. Now, here you can see that one ball, we can apply force like that, okay? And we can change the mass here, like that, okay. First of all, adjust the force and mass, then apply force to C, F is equal to ma, okay. So force 2 Newton applied here, or 1 Newton, like that, yes. So mass of the object 2 kg, right? So force 1 Newton, mass 2 kg, then acceleration F by m, yes, because acceleration is equal to F by m. F 1 Newton, mass 2 kg. So 1 by 2, we will get 0.50 meter per second square. So that is the acceleration. Okay. Now, I will change into the mass for like 4 kg. Okay. Now, the same force. We can keep the force same. Now, watch what happens when I increase the mass. But force, like force, keep the same. Okay. So if I increase the mass, acceleration, you can change. You can see that acceleration decreases, because already we know that acceleration is inversely proportional to mass. So mass increases, acceleration decreases for the constant force. Okay. So force 1 Newton, mass 4 kg, acceleration 0.25 meter per second square. Is it clear? So this is F is equal to ma in action. Okay. Now we will move into the next law. That is third law, action and reaction. For every action, there is an equal and opposite reaction. Yes. So let's look at a collision. Here we have two balls. Okay, right. Yes. Yes. So what's that collision? Equal and opposite forces applied. So there is a equal and opposite reactions. For every action, there is a opposite reaction. Clear? So these are all belongs to Newton's law of motion. Okay, right. Then we will see that simulation for conservation of momentum. Okay, I will share your screen. Wait, please. Okay. So here also, please look at that collision. Here we have two balls. Okay. And with equal masses. So first ball has mass 1 kg and second ball has mass as well as 1 kg. So equal masses, both 1 kg. Okay. First of all, set balls 1 velocity 1 meter per second. Okay. So here you can put that value. You can set that velocity 1 meter per second. And set balls to velocity to 0. Okay. 0. So 0 means the second object is at which is at rest. Okay, right. You can change that elasticity like this. So velocity which gives elastic collision and inelastic collision. So set velocity 100%. So it denotes a perfectly elastic collision. That means no energy losses. Okay. So now run. Observe ball 1 and ball 2. Yes. The ball 1 stops and ball 2 moves. But the ball 2 moves at velocity, you can see here, 1 meter per second into the right direction. Is it clear? Okay. Okay, right. So velocity 1 meter. First of all, that object which is at rest, velocity 0. But now it has velocity 1 meter per second, and it has also momentum because mass into velocity. Mass 1 kg and velocity 1. So 1 into 1, momentum 1. Okay. So now again I will run the same situation. Now please look at that momentum, modulus of P here. For the first object, 1 into 1. Mass into velocity, 1 into 1. So momentum, 1 here. Yes. For the second object, there is no velocity because of it is at rest. So mass into velocity, mass into 0. So 0, momentum 0. Okay. So here, total momentum before collision, 1. Yes. But after the collision, you can see that the same 1. Total momentum after the collision, 1. Okay. So for the ball 1, mass m1, 1 kg. For the ball, velocity 1 meter per second. So momentum of that object. So we can put it 1. Okay. So mass into velocity 1 into 1, 1 kilogram meter per second. Okay. For the ball 2, m2, 1 kg. But v2, 0 because it is at rest. So momentum 0. So before collision, that is BC, total momentum. Total momentum P1 plus P2, 1 plus 0, we will get 1. So this is the total momentum before the collision. Okay. After the collision, the mass same, but velocity changes. So M1, 1 kg, but V1 stops. That is ball 1 stops. So velocity is 0. So which implies P1, M into V, 0. For the object M2, 1 kg, but velocity now 1 meter per second. So we will get P2 is equal to 1. So here we will get total momentum 0 plus 1, 1. So total momentum before collision is same as the total momentum after the collision. So the ball 1 transfers all its momentum to ball 2 after the collision. Okay. Showing that conservation of momentum. Okay. Okay. Let's look at another case. I will share the screen again. Okay. For that inelastic collision, we can change the elasticity into inelastic. So elasticity is 0. Okay. So elasticity 0 means a ball stick together. This is known as the inelastic collision. Okay. So take that object, both object is 1 kg. Okay. Equal masses 1 kg. Ball 1, 1 kg. Ball 2, 1 kg. Okay. Ball 1 velocity we can take as 1. And ball 2 velocity we can take as 0. Okay. Right. So now you can see that mass into velocity, momentum. Okay. Right. Let's run. Yes. Yes. Both balls move together at a slower speed, right? So slower speed, you can see that value of the velocity 0.50 meter per second. Both balls move together at a slower speed, 0.5 meter per second. So the balls stick together. That is known as the inelastic collision. Okay. So here, before the collision, so here our object mass m1 1 kg, object ball 1 kg, velocity 1, and object velocity v2 0. Okay. So here you can see that momentum, first ball momentum 1 kg into 1 meter per second, which gives 1 kilogram per meter per second. This is the momentum of first object. For the second object, mass into velocity, there is no velocity, so momentum 0. So 0 kg meter per second. This is the before collision. So total momentum 1 kg meter per second. Okay. Okay. Right. So now after the collision, just to look at that velocity 0.50, 0.50, mass 111. So combined mass 1 plus 1, 2 kg. Velocity 0.50 meter per second. So then momentum 2 into 0.50, which gives 1. Okay, right? Total momentum. Okay. So here you can see that first object momentum 0.50, and for the second object 0.50, you can add up, which gives total momentum after the collision. We will get 1 kilogram meter per second. So which is same as the previous case, that is before collision. So here also momentum is conserved. Clear? Yes. Okay. So this is a very simple and good exam simulation for that topic, Newton's laws, and as well as consideration of momentum. Okay, let's apply these principles with some numbers. I will solve two problems on the whiteboard. Okay, first sum, problem number 1. A 2 kg object is subjected to a net force of 10 Newton. What is the acceleration? What is the acceleration? If you know the answer, please unmute yourself or chat in the type in the chat box. A 2 kg object is subjected to net force of 10 Newton. What is the acceleration of objects? Anybody? Very simple problem. So you have 2 kg mass and force 10 Newton. Then what is the acceleration? Pi. 5 meter per second. Very good. Good. Super. Great. Very good. Very good. Super. Super. So we can use that formula. F is equal to ma. We have F is equal to 10 Newton and M is equal to 2 kg. So 10 is equal to 2 kg into acceleration, like that. So 2 into A. To find the acceleration, we divide the force by mass. So 10 by 2. We will get 5 meter per second square. So meter per second square is the unit for acceleration. The acceleration of the object is 5 meter per second square. Great. Very good. Usha A50 GJC Parvatipuram. Very good. M Sanga GJC. Okay, Saurabali. Okay, good. Super. Great. Right. Okay. So we will move into that another problem. Problem number 2. So this problem belongs to the concept of conservation of momentum. Okay. So two objects collide and stick together. Already you saw that case. Yes. Stick together. The first ball or first object has mass 5 kg and initial velocity 4 meter per second square. Okay. Meter per second. Okay. So mass and velocity. For the second object, so for the second ball has mass 31 kg and initial velocity minus 2 meter per second. Okay. Then calculate their final velocity. Calculate their final velocity. Okay. So this is a case of conservation of momentum and object collide and stick together. So in the case of inelastic collision, we can see that both objects stick together. Okay. After the both objects stick together, the velocity same. Yes, same velocity. Both object moves with the same velocity. So there is one v after the collision. Okay. So in that sum, suppose if you know the answer for this sum, you can tell that. Otherwise, I will solve. Okay, right. Okay. So this is a sum. Okay. So we use a conservation of momentum principle. Total momentum before the collision, total momentum after the collision. Total momentum before the collision for the first object m into m1 v1, for the second object m2 v2. So this is the total momentum before the collision, and after the collision both masses becomes the combined mass. So m1 plus m2, and it goes with the same speed, same velocity. So vf. Okay. So vf means both objects stick together and moves with the same speed. So that's why vf. And m1 m2 combine together. Okay. So now we will put that numbers. First object has a mass m1 5 kg, velocity 4 meter per second. Yes. So 5 into 4. For the second object m2 31, v2 minus 2. Okay. Minus 2. Here after the collision, mass same 5 plus 31, but the velocity we don't know that velocity. So this is a final velocity. We have to find that final velocity. Okay, right. So 5 into 4 20, 31 into minus 2 minus 62, 5 plus 31 36 into v of 20 minus 62 minus 42. So 42 equal to 36 into Vf. We solve for the final velocity Vf. So Vf is equal to 36 goes here. So minus 42 divided by 36. We will get approximately minus 1.17 meter per second. Okay, this is a value of the final velocity of that object, minus 1.17 meter per second. Okay, good, super. Yes, for APMS Veerapalli, very good, minus 1.72. Good. Okay, good, good. Okay, so here you can see that negative sign. So negative sign tell us that combined object move in the direction the second object was originally traveling. Yeah, our first object originally traveling. So the negative sign tell us that combined object moves in the direction of which one, which object, which is not moving. Okay, so this is exactly how engineers analyze car crashes. By looking at the final state of the vehicles and using the principle of conservation of momentum, they can calculate the initial speeds, which is crucial for improving vehicle safety. Okay, this is a very important applications in our world. Okay, all right. Okay, so time for quick check-in to see how well these concepts have landed. Okay, I am sharing another quick quiz now. Okay, I will set the screen now. Yes. So, first question. According to Newton's first law, an object will continue in state of motion unless. What is the option? What is the answer? Very good. A. Good. Usha's A50s. Yes, very good. Applied force. Yes. Another one. Yes, applied force. Sankar. Yes, correct. Good. So, according to Newton's first law, an object will continue in state of motion unless force is applied. Very good. Good. Many responses. APS, Tambalapalli, GJG, Chittoor, so super. Krishnaveni, good, good, super. Yeah, very good, very good. Then next question, second question. 5 kg box is pushed with a force of 20 Newton on a frictionless surface. What is its acceleration? Use Newton's second law. A 5 kg box, so mass, force 20 Newton, frictionless surface. So that means there is no external force. Then what is the acceleration? 4. Yes, B, yes, 4. Okay, good. Great, great, great. Super. Very good. So 20 by 5. 4. Okay. 4 meter per second square. We will check the answer later. Okay. Third question. Newton's third law implies that for every action force, there is very, very simple one word. A, yes, 1. Yes. Good, good. A1. Okay, okay. Right. Very good. Anandapuram, KGVB. Yes, very good. Yes. So, Newton's law implies that for every action force, there is a equal and opposite reaction force. Okay, super. Good. Good. Great, great. And the fourth question. Two objects collide and no external force act on the system. What is considered? Two objects collide and there is no external forces acting on the system. And what is considered? Kinetic energy, momentum, acceleration, velocity. Momentum, fourth B. Yes, great B. Parvatipuram, Anandapuram, very good. GG girls, Vijay government. Yes, B 970 B. Very good. B. Momentum. Okay, good, good, great. So momentum is concerned. Okay, good. For the final question, a 2 kg object moving at 3 meter per second collides with a 4 kg object at rest. So first object mass 2 kg. So which is at moving with the velocity 3 meter per second. Okay. Second object has mass 4 kg, but that object at rest. Okay. If they stick together, what is considered in this inelastic collision? If they stick together, what is considered in this inelastic collision? Momentum only, kinetic energy only, both momentum and kinetic energy, neither momentum nor kinetic energy. For the fifth question, B. Yes, momentum, yes, B, momentum only, B, fifth B, C, someone telling C, okay, B, okay. For the inelastic collision, okay, for the inelastic collision, momentum is considered. For the elastic collision, momentum is also considered. But there is only one difference between the inelastic collision and elastic collision. Already I told in the class, that is for the for the elastic collision, total kinetic energy is conserved. That means there is no energy loss. Already I told you. Yes. In the elastic collision, there is no energy loss. So elasticity is 0. Elasticity 100%. So there is no energy loss. So total kinetic energy conserved. But in the case of inelastic collision, energy losses. So that means total kinetic energy is not conserved. It's not conserved. So what is conserved in this elastic collision? Only momentum. Yes, great, great responses. Very good. Good. B. Yes, correct. Clear? Okay. So excellent work. Okay. So now I want to hear from you. Can I get a volunteer to explain Newton's first law or law of inertia or second law in your own words, or principle of conservation of momentum in your own words? Anybody? You can unmute yourself and tell that any one concept or Newton first law. It may be Newton first law or principle of conservation of momentum or elastic collision, inertial collision. Any? Or you can type in the chat box. Okay, right. Okay, right. So now the floor is open. What questions do you have for me? Anything that was unclear or that you have to like to explore further? Any questions from your side? Any question from your side? Okay, right. Let's wrap up for today. We covered a lot of concept today. The key takeaways are: first one, Newton's law, 3 laws describe how forces affect motion. Yes, and momentum. Momentum is a product of mass into velocity. And the law of conservation of momentum is a powerful tool for analyzing the collisions and explosion, stating that total momentum in a closed system never changes. Okay? Okay, right. For your homework, I have 3 short tasks to solidify your understanding. Please write this down in your notebook. First one, Calculate the momentum. Momentum of a 0.2 kg basketball, baseball, okay. Baseball thrown with a velocity of 30 meter per second. So this is the first question. Calculate the momentum of 0.2 kg baseball thrown with a velocity 30 meter per second. Second question, in 3-4 sentences, explain Newton's first law, that is known as law of inertia, in your own words. In your own words. You can include one real life example, like a book on a table, or like that, okay, to illustrate it. Okay. Third question. So, third homework. Imagine you are riding a bicycle, okay, riding a bicycle, and you suddenly brake hard, okay. So in that question, I will write it again. So imagine you are riding a bicycle and you suddenly brake hard. Why does your body, so why does your body lurch forward? So this is a third one. Explain this using Newton's first law of motion. Imagine you are riding a bicycle and you suddenly brake hard. Okay. Why does your body lurch forward? Explain this concept using the first law of motion. Yes. Using the first law of motion. Okay, good. So that's all for today. Thank you for your excellent participation. Thank you, teachers, and thank you, students. So if you have any doubts or unclear if in any concepts, you can ask me. Please write that three sum. First one, calculate the moment of 0.2 kg baseball thrown with velocity 30 meter per second. Second question, in a 3-4 sentences, explain Newton's first law, that is also known as Newton law of inertia in your own words. You should include one real life example, like a book on a table, like that, okay? And in the third question, imagine you are riding a bicycle and you suddenly brake hard. Why does your body lurch forward? Explain this concept using Newton's first law of motion. Okay. Okay. Thank you. Thank you all.
Thank you,
Jai
sir.
Bharat. Jai Bharat. Jai Hind. Jai Vidyasati. Thank you.